Okay, this is the same example, and the same example to the PPT by making use of a table. Okay, but let us understand from the textbook, and this is the textbook. How today I am going to explain you about the program linking. The program linking, as you all know, it is nothing but linking the object modules. The linking of the object modules before now, who is that object module? You may be knowing this part is called as an object module. This part is called as an object module. And here the design of a linker is a two-way concept, only in two way. That is program
मैडम
relocation. We need, yes,
जी आपकी आवाज तो आ रही है,
yes,
लेकिन आवाज आ रही है, लेकिन क्षमा चाहता हूँ आपकी स्क्रीन नहीं दिख रही।
स्क्रीन नहीं दिख रहा। ओके,
जी शुक्रिया।
I have presented now. अभी हेलो,
जी बिल्कुल बिल्कुल बिल्कुल, शुक्रिया।
okay, thank you for acknowledging. I was just telling that only. So today the concept of program relocation, and let's take the design of linker as I was showing you in yesterday's class. The chapter only it shows it focused more on the linking, program linking, and the location. Today again I have come up with them because throughout our textbook, I'm not throughout the link of these syllabus, it is explained using example only what is given in the Dhamdre text. Even I am also, this is my screenshot of the textbook called as Dhamdre, and the same example which I have also taken in the PPT. This is the same example. So here, so it becomes more easy to from like this from the textbook. As I was telling, the program relocation and the linking. Why we need such a program relocation? As you all know, how is the steps of a link, and because program has to be executed. To execute the program, what we need the machine language program. And you know very well that how the machine language program is generated. The machine language program is generated because of the translators. Different translators produces different translators in the sense. First translator, which is nothing, the compiler to accept the high level language, and it produces you the it try to do the, or it generate the code. What code it generate? So called high level language, it generate the, and the same code it again the by assembler generate code, not generating assembly language code, and the same language is accepted by the module language. So this machine language program, which is again accepted by the loader, and how it accepts the loader. The loader simply doesn't take machine language program whatever is produced by the linker, because it needs because linker should make ready, everything should make ready for acceptable of the file. So everything has to make ready means it has to go through relocation, and it has to the files for the object modules has to link together, it has to link and make it ready for execution of the program. For this reason, the linker want some memory area. What the linker want? The linker uses some memory area. That memory area is called as work area. In this work area of the memory area only, it starts performing whatever the jobs it has to do. Of the has to do only the program relocation, and it has to make it ready in the sense for the loader, so that loader will have only the executable file. So the linker will produce what? Exe file. So this exe file is accepted by the loader to produce the not exe, loader further produces the exe file, so it starts loading, produces the executable file. That means still making ready of the executable program. The executable program, which will be in the form of the binary program, which will be in the form of the binary language, as we all know that. So the linker want some memory area. What job it will do, why does it want some memory area, and why it has to link, because why it cannot take the whatever the assembler will produce the object module, whatever the assembler will produce the object module, it has to be converted into the executable file. So to convert into executable file, the machine needs it in machine language. In machine language, that is the binary language. So that for this purpose, a memory is a work area by the linker. It uses that memory area to convert this object module, this part, to convert this object module into binary language module. How does it does? That is a question. How does it does? That is a very big question, because program cannot be a simple program. Program will have several units, subunits, everything it will have. And program may also be linked to some other program, and some other program uses the source program. So let us study. So how it comes to, I mean, how does it solves all this? That is called as resolving the resolving what it is also called as resolving the program, or resolving some external references, and it is also called as relocation of the program. Because as the program which is started by the user, maybe at some location address, that program will produce the object module, and this further may not run at the same address by the main memory, may not run at the same address by the main memory. So it may change this address, this 500 address, this may change to start the program. So it may, whatever whatever the memory will find the free slots in it, at that free slot the same program will begin. So this becomes a relocation. This becomes what? Relocation, not only for beginning of the program, it also relocates entire statements in the program. And if there is any linking, who can be that any linking? Any linking is, this program may be utilized by some other unit, So let me show you that some other unit by making use of the same example. Here I have taken the same example. Suppose so here I have taken the same example. Suppose this program is having, suppose this is one program. Let me call this program as P program unit, not a full program, not a full program. Of course, for us, this is source program, one source program. Let us call this program as one P program unit. So this P program unit is referred by some other program. What it is referred by some other program? Here I have taken. I think I have gone very long away. Let me take to the second page. Okay, let us call this program as Q unit program. Let us call this program as Q unit. This program has to be linked. After linking only, after linking, let us see what type of code it produces. Let us see what type of code object module it produces. Now, anyhow, this is a object module it has produced. Let us see what of binary program it produces after linking. So, before linking, it has to do program relocation. How does it does program relocation? How does it does the program relocation? To understand the program relocation, let me tell you one example using this read statement. If you observe this read statement, before the read statement, the program started at the location called as 500 location, and we have some public definitions, that is total. Public definition is the total. By making to make the public definition, we made use of the statement called as the assembler made the total to be used by not only this program, it can also be used by some other program. It can also be used by some other program. Who can use some other program? That some other program is this program. Who is this? This is a, let me write here. It is a program Q unit. Program Q unit. With this, we'll understand the concept of program linking also, and we'll understand the program, the concept of the linker design also, because the linker design is only a two basic concepts, that is program relocation and program linking. So with this, we shall understand how the relocation does for every statements in the program. So program P program unit. So let me write here P program unit, P program unit, and this P program unit, and that below one is the Q program unit. This is the Q program unit. So here you just observe the steps. Even in yesterday's class also I was been telling you the same example. Today which I am telling you about the linker, again it reflects the same example, linker design. So design of a linker also reflects the same. So let us understand again the theoretically the same example. Now here start the program which begins, the P program which begins at 500 location. The P program begins at 500 location, and the total is nothing but this is the public definition, or the public definition which can be used by some other program unit also, or in the same program unit. And here if you observe, it is also used in the same program unit at this because this total, when it is used in the data declaration, data storage declaration, so that becomes as it is used in the P program unit also at the and it has produced the memory location as 541. So here extern is nothing but max and alpha. These both are nothing but something, the reference which can be made to some other program also, and it can also be made the reference to the same program also. So here it is also used in the same program, but they are not declared. So that's what they are called as the extra. When they are not declared means, when they are not declared here in the sense, when they are not declared in the program, in the sense here when you come to the end of the program, when they are not declared here means it is treated that they are still forming as, or they are still becoming as the identifier, but not at defined, not at defined identifiers. But I cannot tell them as not at defined identifier also, but I can tell them as the references. I can tell them, yes.
क्षमा चाहता हूँ, लेकिन
Hello.
कुछ स्टूडेंट आ रहे हैं, उनको प्लीज आप परमिट करेंगे? मेरे दोस्त आ रहे हैं कुछ।
हाँ,
शुक्रिया शुक्रिया।
thank you. Okay. Okay, do acknowledge me in the same way if any student is waiting outside the class. Okay. Now here extend this max and alpha. But if you observe in this program, the max and alpha here are used with this instruction, Max is used with the instruction called as mover, with the identifier called as AREG. Sorry, with the operand called as AREG. And max, it is used with the operand, with the instruction called as bunch on condition instruction with its conditional code, with it, greater than or less than in any. So like that, any is also a part of the, anything is also a part of the branch or condition code instruction. So max is used with this instruction also. So because not yet declared, due to the reason they are made here as 00. If you observe here, what is their object code, or what is their address of max, and the address of max here is why, because in forward reference also, if you see, they are not declared here, they are not declared. Due to that reason it is called here as 0. So such zeros should be resolved, such zeros should be resolved, then only we call it as program relocation. And one more thing, you can also understand the program relocation, how the entire code will get how the entire statement will have the relocatable address based on the starting address, based on the starting address of this 500. So it can be real assumed. Let us assume the same example. If this program is started at 500, if this program is started at 500, so during the relocation, means during the relocation, the set of instructions in the program P, as I said, this is the program P, the set of instructions in the program P that are required for relocations, can be performed by the relocation factor. Now who is that relocation factor? In yesterday's class also I have solved how is the relocation factor. How is the relocation factor? The relocation factor, here I will show you once again. The relocation factor is equal to the relocation factor is equal to the I mean the relocation factor is equal to linked origin, is equal to linked origin. Who is that linked origin? The linked origin is the address which is uh, which is uh, allocated, or which is assigned by the linker during the formation of the binary code of the object module. During the formation of the binary code of the object module, means this is the linked address which is produced by the linker, which is produced by the linker. So linked address, which is linked address minus the translated address. Who is the translated address? The translated address is the address which is produced by the which is produced by the assembler, or which is produced by the starting of the program. The starting of the program is nothing but the compiler only, or translated address. Now what is that what is the relocation factor? The relocation factor for all the entire lines, for all the entire lines. So I am beginning by entire lines, means the relocation factor, anyhow it won't be that much difficulty task for the all the lines. It will be difficulty task for wherever you find the symbols, wherever you find the labels, wherever you find the symbol. Otherwise it will be just the same, relocation address, it will be just same location counter address. So here the relocation the translated address would be for this, the translated address will be for this, the translated address will be for this, the translated address will be for this. The what is the translated address? We usually call the translated address for this line, for this statement is 500, and for this next statement is 501, and for the this statement, move statement is 518. These are the translated addresses. These are the translated address which are of the origin, beginning of the program. Now it is very important that what is the translated address of this instruction A. Anyhow this instruction is beginning at the location called as 500. So how the object module will produce? The object module will produce this, the code of the read is 09, and the first operand is absent here, no first operand, so therefore it is 0 here. And time being A will be here as dash only time being. But when it finishes the forward reference of a, when a is declared, that time it will encounters that what is the address of a. What is the address of a? The address of a is 540. The address of a is 540. Now here the question is how the relocation will be done. How the relocation will be done. So the relocation for this particular operand a, for this particular operand a begins by the relocation factor. Now what is the relocation factor which I was doing here? Relocation factor is equal to linked origin minus the translated address. Now I am doing particularly for the entire program. The entire program, the origin of the program, the origin of the program is started, means the translated address is at 500. Of course, the linked address is 900. I was been telling you since from the beginning. Why I was been telling you? Assume that the linked address, the as the linker takes the object module, so it is having its own address. I mean for this program, because linker will do its entire job with a memory work area. That memory work area is nothing but it is doing the task of relocation, and it is also doing the task of program linking. So it should have some uh, relocation factor. Where does it begins? The execution of the binary program. So that relocation is nothing but the linked origin or the address which is produced by the linker, that is 900, and the original address of the or the translated address of the compiler or the translated address of the the assembler. The translated I must say compiler only, because it is started by the compiler at the 500. So the translated address by the compiler is 500. So what do I get the relocation factor? I get the relocation factor as 400. I get the relocation factor as 400. So this is a relocation factor. Now the question is that all the instructions set, because all should change now, all should change, because once we have the relocation factor as 400, so internally all of the addresses will get changed, because it is starting by 900 instead of 500. Now in linker it is getting started at 900, it is getting started at 900. So internally all of this will get started at, now read a will start at 900, accordingly it will get of course the code, machine dependent code will be the same. So read will have the opcode value as 09, and first operand value is not there, so it is therefore 0 here. And the address of a is at 540. Now it is started at 900, therefore it will have 940, now. So the entire, what it is, IRRP, what it is called as IRRP. I let the IRRP be the set of the instructions in the P program that required to be relocated, So IRRP is nothing but the set of instructions which are required for relocation, So we'll have the translated address. Let us see. Now for the next line. Now for read, it is at 500 anyhow. This statement is at 500. This statement. Now, statement only I am telling. Why? Because IRRP is nothing but entire instruction sets in the program P. Entire instruction set. Now let me write here the term which I am using. IRR. IRR in the sense, and the subscript which I will be using as P in the program P. In the program P. Now this I will bold in the program P. This IRRP is nothing but for all the instructions. What should be the how it manipulates the code? Now let us see. Now here we have found. Here what we have found, it is for the first line it is at 500. And for the next line, anyhow there is a label, anyhow there is a label, so it doesn't have any instruction here, it doesn't have any instruction, therefore it is started at 501, therefore it is started at 501. But this label is treated to be as a symbol, and it is this symbol will be pushed on to the symbol table. Anyhow a was pushed on to the symbol table, that's what first time I kept here as dash, and later when a was declared at the end of this line, that time I am telling here it is at 540. Now for this loop, it is a second entry in the symbol table, so this second entry of the symbol table will be pushed down to the symbol table. I mean this loop is a label, will be pushed down to the symbol table. After that, as I location counter will be increased, as I come down here, here I have again another instruction IRRP instruction set, and here also again I have another IRRP instruction set. But for this here itself only it decides its address for this line is 518, and the code for MOVR is 04, and AREG anyhow it is a category of 1, that is the first operand. And of course alpha it sees the end of the line, and of course alpha is not yet declared, therefore not yet declared anyhow, because though alpha and max are being as in this program as the identifier, it is not yet treated as identifier in this program. Why? Because they are declared as external reference variables. That is what, when they are not declared here by using as ds, when they are used as ds, that time it can be called that time it can be given as the memory address, sorry, the address will be generated here. Therefore alpha and max are 00, see here 00. Anyhow NE is having the code as 6, and BC is having the code as 06. Why 6? Maybe GT will be having 5, LT will be having 4, like that. It all depends. Now when I come to this line, dash dash means it is treated that there are several lines. When I come to here again, BC, branch on conditional code on less than, again the loop, this variable is found. So branch on anyhow again the same code 06, and LT is 1, LT is 1, GT may be 2, NE is 6, likewise. So here LT is 1, and here you see it is found at 501. Why it is found at 501? Because loop, because it is a loop, and for loop it is a label, and for that label its address was found to be at 501. Its address was found to be as at 501, and loop is a label, that's what here it is not at declared as data storage. Loop is a label, but it is not yet declared as a data storage. It's a label because the condition code, it has to branch to this address location to this address location. So it is just the transfer loop is taking here. So here it is 501, here it is 501, and very importantly you should make note here, this is the translated address for this loop, for this instruction, for this instruction. So IRRP is nothing but instruction set. Now anyhow here loop was simply used, but the location counter of the address was increased here, it was increased. But when the same loop was utilized in some instruction, that time this address is very important, that time this address is very important. What is that address? 538. Now this 538 is nothing but the translated address of the loop, is nothing but the translated address of the loop. Now I can say the location is performed by the relocation. The relocation is performed by IRRP, means now loop is using this instruction BC. Now A is using the read instruction. That is what these two lines are very important. Which line? The line called as 500 and the line called as 538. Getting the line called as means the address line called as at this instruction, read instruction, and the address line at this instruction BC. So this is treated to be as the, I mean, now the relocation will perform. How the relocation will perform? Based on this, depending on this, when the program is started at 500 minutes. Now, depending on this, when it is started at 900, of course, it will start at 938. Of course, it will start at what? 938 or some other. Let me do the calculation based on the relocation factor. I'll tell here based on the relocation factor. So the instruction, I mean here, the instruction with the translated address are what? The instructions with the translated address of IRRP are 500 and 538. What are the translation instructions? Instructions. Who are reflected? BC is the instruction. Read is the instruction. That is what. Why read is reflected here? Because A is found with that. And why BC is reflected here? Why this instruction is reflected here? Because loop is found with that instruction. That's what IRRP means. Instruction relocation of this instruct IR is instruction relocation in this program we are going to do. So that's what this address of the translated address of 538 and the translated address of this instruction called as read 500 and the translated address of BC is 538. So with this translated instructions, 500 contains 500 contains the 540. See here, 500 contains the 540 and 538 contains the 501. See here. Correspondingly, now you need to understand during the time of relocation. During the time of relocation. Okay, now I'll repeat. The instruction with the translated address 500, the instruction, who is the instruction? Read. The instructions, the instruction with the translated address of 500 contains what address? Contains 540. Contains 540. Next, the instruction with the translated address of 538, the instruction, who is the instruction? BC. BC is the instruction with the translated address of 538 contains 501. Why 501? Because loop was found at the address called as 501. Because loop was found at the address called as 501. And A is found to be as a forward reference, and because A I want to utilize in the program, that's what it is declared, and it is found at the 540. And it is found at the 540 in the operand. Okay. Now this address is changed. Now this address is changed to what? This address is changed to 540 plus 400, which I get as 940. Which I get as 940. And the instruction with the translated address of 538 contains the address of 501. Contains the address of 538. See here. Contains the address of 501. Contains the address of 501. So with this field, I will get now the instruction as what I will get? I will get 400 plus 501 means how much? 901. Did you got? I'll do here now with the relocation factor. What do I have relocation factor? The relocation factor which I have as 400. I'll do here. I'll go to the down, I mean to the bottom only. The relocation factor. This is, I treat this as my virtual board of MS-DOS. MS Office, sorry. MS Office of Word. Yes, Onkar, are you understanding? Onkar? Yes, Onkar? Now, okay, it's not getting copied. I'll go directly do here down. As this is the program unit called as. This is the figure of the program unit called as Q. Onkar, are you understanding, Onkar? Yes, Mukund. Okay. Now here I'll make you to understand about. Okay, here I'll tell you to understand the relocation of operand A. Now I'll tell you here what the relocation factor I have. Relocation factor I have for the program P, for program for the program P as 400. Relocation factor for the program P as 400, and the instructions of the relocation factor for all the instructions of the operands. Now the operands, wherever it is used with the instructions for the program P, is with what? Is with instruction called as read, and with BC, is with read and BC. So with read, A is found to be at. Now with this relocation factor only, how the address will get changed? The address will, if it is now relocation concept for all the instruction set, that I will tell as IRRP. IRRP. P is nothing but your program. So I'll use here subscript, small subscript. Yes, understanding. Hello, Sonia. Onkar, are you there? Pooja, Ahalya, Aparna, Sonia, Neha, understanding? Okay, Aparna said yes. So now the relocation with this I mean, what is this? This is nothing but the relocation factor. I will write here relocation factor. Relocation factor. As I got the relocation factor as 400 for the program P, wherever now the instruction, wherever now the operands or the labels are used with the instructions. So IRRP is that instructions. In the program P is read and BC, it is used. With the read, A is used. With BC, what is used? Loop is used. So the relocation concept for all the instructions, all means here I will get only two, that is read and, so I will get here as 540 plus the relocation factor. Now 540 is nothing but your the translated address. 540 is nothing but the instruction with the translated address. The instruction with the translated address is found is found at 540. Is found at 540. This 540. So with this I will get for A, what value I will get? Means I will get here the value as 940 for A, for whom? For operand called as A. For operand called as A. Next one, here in general I will write the translated address Now it is for operands. So that operands are nothing but the symbols or the operands which are used in the program. So that is represented as the translated address of the symbol T, small t, the translated address of the symbol. Now subscript in yesterday's class also I have shown translated address of MB, translated address of the symbol. The translated address of the symbol will be getting, this is for relocation, the translated address of the symbol with relocation factor plus the symbol, translated address of the symbol. So the translated address of the symbol I will call as L origin, which indicate as real L origin, which indicate as linked origin. L origin. Again subscript, small subscript I need to use origin. L origin is equal to L origin is equal to translated address of the symbol plus the relocation factor. Relocation, perhaps I will be using, okay, let it be relocation factor. L origin is called as the linked origin. Now how it is linking? Because it is done by relocation happens in linker only. So I am doing for relocation. Relocation is the concept which is done by the linker, and linker will begin the address, a fresh address. Wherever the memory is free, it will start there. So it is called as, even it is called as linked origin. Relocation, here I'll write linked address or linked origin address. Here, okay, I'll write in bracket. You should not be confused. So linked address or linked origin is the relocation address of the program or for entire statements. Now for all the instructions, IRRP is for all the instructions. Now all instructions means I have only read statement and BC. Read statement and BC. This is reflected to the symbols. This is reflected to the symbols. So here I am getting here the linked origin for symbol A. What is this? For symbol A. Here left side I will be writing for symbol A, the linked origin, linked origin for symbol A. Symbol A which is found at, what it is, 540 plus 400 is equal to 940. Why 540? 540 is nothing but your translated address. What is the translated address by the compiler? Is at 540. Once again you can see the program. Oh my god, this has gone. No? As I am going down, it has gone. I think it is linked. Okay, let me see down. Here it is. But this is for linking concept I'll use. See here. What is the translated address? These are your translated addresses at the beginning. These are the translated address by the translators. Who is that translated? By the compiler. These are the translated address by the, or these are the addresses which are given by the compiler. translate. That's what we call them as translated address. So the translated address for A, which is found at, see here, 540. Now come down, you can see the translated address is 540. Here I will write, again it is making confusion. I'll make copy this, paste, is equal to, again which I get as 940. Now this is the 940 is the linked address or the linked origin for A. Linked origin for A. Have you understood? 940 is the linked origin for A. Same way, we need to do the linked origin for, same way we need to do for the linked origin for loop. Now loop is also a symbol. Of course, it's a label, but it is treated to be the as the second entry in the symbol table, and it is not declared. It cannot be declared. Why? Because loop is taking as the it is not used for computation. It is taking as the control transfer within the program. That is what it is found at the address. Whatever the first address was found, it is not at declared. So it is found at 501. Loop here there are, otherwise it would have been found its object code here itself only, object model here itself only, if the code is here, sorry, if the instructions are here. But loop is used here, it is keep looping and having some code, and after that again loop was called here on less than. Again the loop label was called here with this instruction BC. That's what this address is found at 501. Already it is found, already it is seen. So its address is at 501. So how the linking address will get changed? The linking address during by the linker will get changed. So the entire code is getting changed. Entire code in the sense entire instructions. Entire instructions are getting changed accordingly. Now the linked address, or linked origin for loop, linked address or linked origin for loop is equal to symbol, this symbol, translated symbol, the translated origin symbol. What is the translated origin of the symbol? The translated origin of the symbol is found with the instruction is at is at where it is at, um, the translated origin of the symbol is at 501. Just now I have shown you. Translated origin of the loop is found at 501, which is added with the relocation factor. The relocation factor is 400. The relocation factor is 400, and with this it is getting the answer as 901. It is getting as the answer as 901. Now this 901 is the new address generated by the linker, or I can tell it is a linked address, or I can tell it is nothing but the address generated by the linker, or it is nothing but relocation address. It is nothing but a relocation address, new relocation address in the memory, main memory. So that is the program. This is the concept called as the program relocation. What is the concept? Program, how the relocation happens. Program relocation. This is the concept called as program relocation, or it is nothing but linked address. Now with this program relocation is not enough. This is what it happens in the memory area. The memory area which is required by the linker. This is the first what it does the job, and the next job it has to link. Now the relocation is happened for this program. Assume that now it has to do the linking, which it has to make ready for executable file. But this file, as I said, it is a one program unit. It is some subprogram P. Now there is another subprogram that is Q. This program, I said, this program is called as another subprogram unit called as Q. So for this program unit, which is referred by the P program, Now look into this program. Now the concept which I am explaining here is program linking. What it is? Program linking. Now these two concepts, program relocation and program linking, are nothing but the design of a linker. Yes, Onkar, understanding? Onkar, program relocation, it has to make set for the fresh entry in the linker, the fresh entry in the memory area, so that it should make ready for the executable file. It should set all the designs, it should set all the pros and cons for making the ready in the program to run in the main memory, so that this again to run in the main memory, it accepts the executable file which is produced by the linker, and it start executing in the loader, by the loader. It takes in the main, again their memory also it gets changed. Loader also will have some fresh memory locations, so that we'll see in the loader chapter in the next week. So here now I am showing you the linking. Now if you observe this example, yes, are you understanding? Are you understanding, Mukund, Yogesh, Jitendra? Are you there in the class, or just simply kept your mobile on? Pranali, Pooja, Rutvij, Jitendra. Okay, some students are telling yes. Now, Rasika, are you understanding? Okay, now I will tell you program linking, how the linking is done. Now the program has to see the information whether is there any program linking, whether this program, whether the source program is linked to another program or what. So it will find that there is a linking with some other program, that is Q. How it will find that the same alpha is used here? How it will find the same alpha is used here? That's what, as alpha was the external reference. Now entry means it became here as the public definition in this program. In this program, it became as public reference, but this alpha was used as the external reference by the program P, where by using the program P, now it has started using that alpha in this program Q. So when it has started using the alpha in this program Q, so what it has to do? It has to do the program. It has to declare the program. That yes, somebody is making noise. Somebody is making noise. Keep your mute, or if you have any doubt, you can ask me. Chitol, Siddhi. Some disturbance was there. Now, which I was telling you about the linking. The linking, it has found that the alpha is used in somewhere in this program. So when alpha was treated to be as an external reference by the program P, program P is giving some variables. So program P is giving some variables. Already it was the alpha was used by some condition. Already the alpha was used by some condition, some instruction. If you see, I will just go with the screenshot. Sorry, pick, because again traversing up it takes time. So I'll use this screenshot. See here, alpha already it was used and it was declared here. And in during the relocation, maybe it got as 918. What it got? 918. Now this is changed in by the linker. It is changed as 900, and this is changed as 901. This is changed as, I mean, relocated as 918, 919, 938, 939, 940, 941. Okay, like this, so on. It was found 901 like this for this. So we have also seen how the relocation address also we got by the linker for these two variables a and loop. A and loop, see here, of course here total is used, is declared, is that means it is used. Maybe here dot is there, no, somewhere dots, here dots, maybe the total is used here somewhere here in the program. So that part is the third example which makes us the relocation example for this variable. Okay, third symbol it makes, but that is not used, sorry, that is not computed in the example. Only these a and loop we have computed how the relocation has been done. Have you understood the relocation, how the relocation is being done? Now if you observe here, the alpha here, this alpha is used as the external reference. So this alpha to be used as the external reference, that is what the program Q is using this as the alpha. So to use this as alpha, of course it has to make as the public definition. Of course it has to make as the public definition because it is used as an external reference. Do you remember the primary keys and the referential keys in DBMS? So like that. So when you are making that, when it was made as the external reference, of course I need to declare once again in the program, in my program queue. So I have declared it, but I have declared again as globally. That is called as entry. To make it as global means public definition, who anybody can be used. Program P also can be used, program Q also can be used, anybody can use. So this variable, so to use anybody, so I made here as public definition, I mean PD, and to make it as PD, public definition, so we need to use here the statement called as entry. So that statement called as entry, again because I am using it in my program queue, so therefore I need to declare it by saying as data storage of the word as 25. So the value is given as 25 to that. So that 25 is the value, data value for this alpha. But if you observe, what is the address generated for this? The address generated for this address is nothing but the program generated at the by the translator. This is the address generated by the translator. 231 is the address generated by the translator. So how that linking happens now for this? How the program linking does. The program P contains an external reference, as I said, to the symbol called as alpha in the instruction with the translated address as 513. What was the address? Now you observe here. For alpha, I got as 518. See here. For alpha, I got as the translated address. This is called as translated address time also by the translator. Translated address time by the translator. 518. What is the address which is given by the alpha? It is 518. By whom? By translated address, or I can tell as translated time. Means you should think that here it is the address generated by the translator. 513. Okay. Now what is the linked address? The linked address origin by the linker, we link by the origin. It is started at, for the program P, it is started at 900 and the size is also given. I did not told you the size. The linked address which is divided for the program key, it is 900. Anyhow, it is started at 900. Anyhow, it is started at 900. But this is the relocation factor which we got 900. But this is of 42. But the size is of, hence it will give the size also. The linked address, therefore now the linked address for the queue, what it will be given, address for the queue, it will take 942. It will here, it will begin at 942. I'll write here. Therefore, now by the linker, the linked address, it is therefore 942. Why it is 942 for the program queue? Can anybody tell, Onkar? Why? Because the linker already gave for the program P, which it has to start at 900, and the size it has given as 42. Therefore, this one, no, this linked address, it will start at what? 942. Therefore, this for the program Q, it will, now I'll write here. For the program Q, it will start at 942. Therefore, for the program Q, it will start at 942 is the linked address, and accordingly the linked address of the alpha, what it will be? Now accordingly the linked address of the alpha, now this was the translated time address. This was the translated time address of the alpha. Now I'll take here. This is the translated time address. The translated time address of alpha is the translated address of alpha is the translated time address of alpha is 918. Now what it will get? Translated time address of alpha. Just the example. Recall the example. 942. 942 translated address. How it will get added? As it will get added as 518 plus. It will add to the previous 518 plus 942. Yes, are you in the class? Yes, hello. Onkar. Hello. Hello. Are you there? Pranali? Hello? Hello? So now it will be found at 973. So this is what is called as resolved by putting the link address of the alpha at 973. Okay. So after resolution, it will get the address as 973. This is called as linked address. Linked address, or it is also called as the resolved address. linked address or resolved address. Earlier which was found at 518, now it will be found at 973. Hello, roll number 1.
Present.
Roll Yeah, have you understood?
Yes, ma'am.
Okay. The address, new address of the alpha will be found at 973. Okay. Why? Because the earlier address of the alpha was found at what? It was found at 518 in the program P, and to that you add the address. Now it is having at 231. How? Because in program Q the linked address, it is found to be at 973. How? Means because the alpha definition is found at 231. The alpha definition is found at 231. So with this 231 plus the earlier address, we get 973. So 4, okay, with this. So this is how program linking and program relocation. Roll number 1, 2,
Yes, ma'am.
3,
Yes, ma'am.
4, 5,
Yes,
4
ma'am.
present.
6,
Present.
7,
Present.
8, 9,
9 present, ma'am.
10,
Present, ma'am.
13, sorry, 11,
Present, ma'am.
12,
Present, ma'am.
13,
Present, ma'am.
14, 15,
Yes, ma'am.
16,
Present, ma'am.
17,
Present, ma'am.
18,
Present, ma'am.
19,
Present, ma'am.
20,
Present, ma'am.
21,
Present, ma'am.
22. Hello. 23,
22 present.
23 present, ma'am.
24.
Present.
Okay. 25,
Present, ma'am.
26, 27, 28,
28 present, ma'am.
29,
Yes, ma'am. Present.
30,
Yes, ma'am.
31.
Yes, ma'am.
Have you understood this part? In program Q 31.
Yes, ma'am.
In program Q, we have no operands here. So here, no instruction. Here, no instruction. So therefore, we have 0 for no instruction. Anyhow, for DS also sometime it will be calculated, but DS it is having 0 0. DC it is having 0 1, and here no operand, one, no operand one, so 0. So the value we have there as the second operand, so it is 25. But this full instruction is found at the address called as 231. 231 plus the 742 you need to add here to get the new linked address for the program Q for this alpha. So this, by putting this, it is called as a resolved address as 973 you will be getting. Have you understood?
Yeah, ma'am.
28, 28, 29, 30, 31,
29
32,
Present, ma'am.
Yes, ma'am.
29 is present.
28 present.
Okay.
Yes, ma'am. 29 is
Okay,
present.
okay. 32,
30 is also present, ma'am.
32 I said.
32 present, ma'am.
33, 34,
Present, ma'am.
35,
35 present, ma'am.
36,
36 present, ma'am.
37,
Present, ma'am.
38, 38. Hello? 39,
39 present, ma'am.
40,
40 present, ma'am.
41,
Present, ma'am.
42,
Present, ma'am.
43,
Yes, ma'am.
44,
Yes, ma'am.
45, 46,
Yes, ma'am.
47,
Yes, ma'am.
48,
Present, ma'am.
49, 50,
Present, ma'am.
51,
Present, ma'am.
52, 53, 54, 55,
Present.
56,
Present.
57, 58,
Present.
59,
Present.
60, 61,
Present, ma'am.
62, 63,
Present, ma'am.
64,
Present, ma'am.
65,
Present.
66, 67,
67 present.
68, 69,
Present.
70.
Present.
Okay. Have you understood how the resolved address it will do after, a resolved address it will do for linking of the program. Accordingly, this last part you need to understand, very important. So the alpha was found in the program P, which was found at the address called as 518. Now, and in the program P was having the size by the linker which is generated at 942. So this queue will start at, accordingly this queue will start at the address called as 942, and correspondingly what the address it was having as 518, there correspondingly it will get as 918. So here also correspondingly here it will get as 973. So this is the resolved address for the address, and this is called as the linked address also, and this resolved address will be put into the will be kept as the reference for this alpha, and this resolved address is used by this alpha for calculating the object program, or for calculating the binary program by the linker. Okay, so this concept is called as the resolving concept also, and this concept is also called as the program linking. So with this, I have told you the concept of how the program relocation and program, not only program relocation, the program linking also we have come to know how does it does the linking. But here it is very important again, what the headers will be there, what are the informations of this object module, this object module, what are the informations about this object module. Now this is, this is called as the object module. What are the informations contained in the object module? The informations which are contained in the object module will be of the 4 component. Now those 4 component are called as header, program, and program relocation, and linking table. Just now we have seen how the object module will have program relocation. Now here it is it will be very wrong if I call this as the object module. I must say for the same program as object module in relocatable. Now 090 04100, this will be resolved. Now here it will get as 973 alpha. What the alpha will get here as? Alpha will get here as, because of this correspondingly, as it was at 918, where I have solved here. So correspondingly this will be found at 973, as it was having here as 00. So here 973, here it will be 940. Now this 00 also will be refound. Maybe this max is used by some other linking. So here based on that correspondingly here the address will be generated. Now here it will be 901, here it will be 901, and for this stop anyhow we won't get any address for this stop anyhow. It will be taking because as start is having some operation code as 01, stop also may take as 02. So there won't be, because in stop there is no operands, operand 1, operand 2, so it is 00, and the stop maybe start it will take as 01, the stop maybe it will take as the code as opcode as 00, and there are no operands here, therefore here it is 00. Usually for stop it will be 0 only, so we need not to worry about that. So whatever the address are located by the linker, that address located by the linker, further it will be converted into binary program module. That binary program module we call it as machine language. That machine language will be, now how it will be. Now this object module, as I said, it has got 4 content: header, program, relocatable table, and linking table. Again further they will be having, who were the relocatables? The relocatables were for alpha and for max were relocatable, and for A also. Now in this program A is treated to be as as A is treated because A is also treated to be as the public definition. So if it is treated to be as the public definition, because anyhow A is identifier, but in linking it is treated, it will not be called as a symbol, it will be called as public definition only. Maybe some other program will be used. So all the identifiers will make a list, and they will be who are the linkable address. So it will make a list, and who are the relocatable addresses. So it will make a list. The relocatable addresses are at 500 and at 538. Why? Because A is red and B and loop is red. A is red with the instruction and loop is red. So with this correspondingly with this instructions which they are treated to be as relocatable for 500 and 5 for 530. So these are relocatable address. Further they go and get changed as 900 and 938. Then who are the linking addresses? The linking addresses are alpha here. The linking addresses are alpha and max, and also maybe A also. So with this correspondingly their addresses, wherever the alpha is used at 518, and max is used at 519, and A is used at 540. So these are linkable addresses. So I will show that using the I'll show that using the figure which I have downloaded here. Maybe two I have, yeah, here. This one. So who are the translated addresses? The translated addresses with respect to instructions, with respect to A and with respect to loop, the translated addresses. These are 500 and 538. And who are the linking addresses? The linking addresses were with respect to extern variable and also with respect to A also. Why A? Because with respect of this program, full program, A is treated to be as the public definition again. So A and all these extern variables, because extern variables are also used in program Q. So it will find out who are the variables in program P and in program Q. So in program P, A is there, and in program Q, alpha is there, and in this max is also used here, alpha and max, and also it was used there. So alpha and max were extern variables. So that's what it will treat it as the external variable, and A it will treat as public definition. So they were found at the address as 518 and 519 and 540. If you see here, so if you see here 518, 519, alpha and max, and A is found at 540. These are the variables. Okay. These are the linking variables with respect to instruction, IRRP. See here, with respect to instructions. A was used here with respect to instructions, 518, 519. So that's what they were called as linking addresses. So these are the components. What these are? These are nothing but the components. What components? Object module component. Who were the object module component? Once again, I'll just download the figure. Who were the object module components? The object module components are header, program, and relocatable. This figure. So these are nothing but the object module components: header, program, relocatable, and linking table. Relocatable and linking table. Relocatable will have the translated address, and linking table will have the again three component it will be having, that is symbol, type and translated address, which I have shown here in the other figure. Symbol, type, this is the linking table, symbol, type and translated address, symbol, type and translated address in linking table. In linking table, I mean it's fields of the linking table. What are the fields of the relocatable table? The fields of the relocatable table are translated addresses. Who are the translated address? The address which are generated by the translators for the identifiers. And the addresses linking table. Who are the linking identifiers? The linking identifiers are alpha, max and A. These are the linking symbols in both the program P and program Q. So they were found at the addresses, translated address, and correspondingly this it will get changed. This will become 900, this will become 938, this will become 918, this will become 919, this will become 940 correspondingly. This is at the relocation, program relocation. We have seen both the concept and also the concept of the object module. And sorry, not concept, what the object module consists of. This is what the object module consists of: the header. The object module consists of the header, program, relocatable table and linking table. Header means the head of the translated version and with the size, like size I have told as 42. Okay, and the program, this component contains the machine language, which is nothing but the binary. And relocation, relocatable, who are the relocatable addresses, which describes for IRRP. See here, which describes for IRRP. Who are the IRRP? The identifier which were with the instruction sets. Who were the instructions? Read and the BC. Who were the identifiers? A and loop were the identifiers. So what is their translated address? So that is the field for relocation table. And linking table, what is the translation field for linking table? So the fields of the translation, symbols, what are the symbols which are used in both the program linking units, that is program P and Q. In both the program, it was found that A, max and alpha. A, max and alpha were found, and what is their addresses? The addresses were 518, 519 and 540. So this is what the program linking, program relocation, all concept. This is what overall design of a linker. Tomorrow I'll be explaining with the help of the algorithm. Thank you all. Okay, any doubt? Onkar? Any doubt? Sonali, Pranali, Onkar, Mukund? Any doubt? Check. S. Patil, Preeti, Pratik, Jitendra, Saurabh, Onkar, you are not responding.
नहीं मैडम,
ओंकार,
कुछ दिक्कत नहीं है, अगर होगा तो जरूर पूछ लेंगे। ये क्या है, मुझे आवाज काफी वक्त से रुक के आ रही है, मुझे कुछ समझ नहीं आ रहा है।
समझ में नहीं आ रहा,
आवाज ही रुक के आ रही है सब।
ओह माय गॉड, तो आपका ही प्रॉब्लम होगा ना?
मेरा ही प्रॉब्लम है शायद, मेरा, क्योंकि जब मैसेज कर रहा हूँ चैट बॉक्स में वो भी नहीं जा रहा।
वो भी नहीं जा रहा, मुझे तो नहीं दिखाई, एक ही दिखाई दिया और 213 को। प्रीति, are you understanding, Preeti? Okay, all of you maintain your attendances for all the classes. Thank you all.
Hello, ma'am.
हाँ,
Roll number 8 is present. Due to network issue, she was left from meeting.
roll number
8.
हाँ,
roll number 8.
Write in a chat box otherwise. Text me. Roll
Hello,
number
ma'am.
18.
Roll number 14. Roll number 49 is also present. Due to network issue, she is unable to give her attendance.
Okay. Okay. Thank you. Tomorrow I'll be explaining with this. The linker chapter will get over. Tomorrow I'll be explaining about the algorithm. That much only. Okay. After that we'll begin for overlays are nothing but the overheads. What are the overheads? What are the disadvantages? So that can be covered in one class. But in next week I'll be starting the loader, because it should be very back to back. Then only you'll understand how is the linker and loader. Thank you all.
Hello, ma'am.
Yes.
Ma'am, can you read out the absentees number?
Absentees. Okay. It is 14, 15, 16, 26, 27, 38.
Hello, ma'am. Roll number 38 is present. Due to network issue, she unable to.
Okay.
Ma'am, 16 is present.
15.
16, ma'am, 16.
Okay. Next. 16. 15 is there. Thank you all.